Now we'll look at some more solving exponential equations. Here we have the equation 8,967 equals e to the 4x power. So I've written a list of steps here for us. Remember, the first thing that we want to do is to try to isolate that exponential term on one side of the equation. And here it is. E to the 4x is on one side of the equation by itself. If there is a coefficient of that term, we want to divide by that. But here there is not a coefficient, so we don't have to do that step. The next step is to take the logarithm on both sides of the equation. The logarithm is what's going to undo the exponent. So if here we have an e to a power, so we want to take the natural log on both sides, because the natural log is the inverse of e to the x. Okay, natural log of x is the inverse of e to the x. So when I take the natural log on both sides, then I'm going to solve my equation. My property of logarithms tells me that if I do the natural log of e to the 4x, that's just going to give me 4x. And then I still have the natural log of the 8967 on the other side of the equation. But now remember, this is just a number. The natural log of this number is just some number. And here's my x. So to get my x by itself, I just need to divide by 4. Just be careful when you put that in your calculator. You want to be sure to do the natural log of 8967. Close the parentheses before you divide by 4. And that gives us approximately 2.28 for the value of x. Now this problem does say, and check this problem graphically. So to check this graphically, remember to graph the equation. You're going to put one side in y1 and you're going to put the other side in y2. So I have y1 equals 8967 and y2 equals e to the 4x power. Let me get that to focus a little bit better there. Okay. Now, when I go to my graph, I first want to be sure that I can see the graph. The window I'm on here, I don't really see it very well. Okay. Remember that first equation is y equals 8,967. So that means my y's need to go up to at least 9,000. So let me set my window where my y goes up to, let's make it 10,000. And I'll make my tick marks every 1,000 units apart. Now let me see if I can see this picture a little bit better. There's my y equals line. And I do see the intersection here. I could have gone even higher with that. My intersection, I'm just using it to check myself. So I'm going to do second calculate. I want to find where that intersection is. So I'm going to arrow, choose calculate intersect, and arrow over to the intersection. And I get that it is 2.28. Now let's look at one more problem. One more exponential equation to solve. Let's come down here and look at this one. Solve the exponential equation. I still have a big constant there. 4,096 equals 8 to the 2x power. Steps are get the exponential term by itself on one side. I've already got that. Divide by a coefficient. I really don't have a coefficient. It's just 8 to the 2x power. So now I'm going to want to take the logarithm on both sides, solve the equation, and then check it. So if we look at this, here my base is 8. It's 8 to a power. So I really don't have another logarithm. It's really not applicable to undo log base 8. To take log base 8. We'll just take the log on both sides. Just a common log or just a natural log, either one. So now, after you do that, you can use your properties of logarithms. The whole reason you're doing that is so you can use your property of logarithms to pull this 2x out here in front. So that gives you the log of 4096 equals to 2x times the log of 8. Okay, nothing's in the exponent up there anymore. Log of 8 is just a number. Log of 4096 is just a number. So if we want to solve this by solving it for x, isolating that x, I've got to divide by 2, and I've got to divide by the log of 8. So I'm going to divide by 2 log of 8 on both sides of my equation. Then, let's see what that gives me. If you're not real familiar with your logarithms, let's see what that gives me. If I take the log of 4096, close parentheses, divided by, now let's make sure all of this goes in the denominator. So I'm going to do parentheses, 2 log of 8, close the parentheses around the 8, and then I'll close the parentheses in the denominator, and I get that gives me just a plain old 2. And you can check that by plugging it into the equation, or you can check it graphically.